So reminders. We have the decorator lab that's up now. I forget when I made that due. I hope I made it due after the 8th. Next Wednesday. My recommendation is to get started. If your experience with the strategy lab was, that was harder than I thought it was going to be, that will probably be something that is consistent across the labs in this course. They're going to take longer than you think they will. Hopefully, most of the one-off issues like, how do I build a project? Where do I put my source folder? Those are more one-time questions that you asked during the first lab and don't really need to be asked again once you figure out how to do it. So that should be minimized going forward. But the issues that you run into, like these particular tests aren't working for some reason, that will be consistent across many of the labs. And you'll have to figure out why is that as you build up the tools for handling those unforeseen issues, especially with code written by someone who is not you, which will be most of the rest of your career, assuming the rest of your career is in computer science. So today we're going to be going over the next design pattern that will also have a lab associated with it. And once you complete this lab, and even while you're completing this lab, we will have the ability to introduce the project. So the rest of the quarter project is coming very soon, and we'll just be working on that on top of the labs that are introduced, except that the project is my design instead of prior people who have taught this class's design. So it offers significantly more freedom in terms of what you can do, but with that power comes great responsibility, and that responsibility is to go through a solid design process before you get started, otherwise you will get stuck. And this is going to be a very large project of 20 or 25 classes, most of which do very little, but the structure of that is very important. So once I introduce the course project, we'll probably start transitioning from having Fridays being the solving fun problems day to Fridays being the work day on the project. And what I will want to start doing is have people brainstorm and think about the UML diagram for their solution. Maybe they'll come up, draw some UML diagrams on the board, and they can get the class's feedback on what's going to work, what's not going to work. So we can start making this a bit more of a collaborative process as you design your own solution to this project. Much more my style. So that's where we're going, but to get there, you need the one last design pattern. We've covered strategy, we've covered decorator, we now need to cover builder, because those are the 3 design patterns that you're going to be implementing in your project. So we've seen design patterns from 2 of the 3 different big groups that we've seen. We talked about there are creational, there are structural, and there are, what was the third one? Behavioral. Creational, structural, and behavioral. So we've seen a structural and a behavioral. The behavioral was strategy, the structural was decorator, but now it's time for our first creational pattern in builder. Creational patterns often have to do with the process of object creation. When we don't have enough power in a single constructor method to be able to handle the object's construction. We want to offload that and create some more power and support throughout the object creation. So builder is going to be the first dive into this. In fact, the next couple patterns we cover will both be creational. So we find that as we're trying to put together an object, the construction is more complicated than you would expect, needs lots of input from the user. And as you do this, you'll find that one of the code smells that we just talked about, a long parameter list, is being passed to that constructor. The example that we're going to use for this is, you're going to Disney World. Much more exciting than attending classes for the remaining 5 weeks of the quarter. But now we can imagine that we live fun lives instead of our boring everydays. We're vacation planning, we're going to Disney World. As we do so, we need to construct what this vacation is going to look like. What are we doing on each of the 3 days of this vacation? What are we doing for our lodging on each of those days? What are we doing for our food on each of those days? What are we doing for our travel? So you can imagine that a vacation object is broken down into a number of day objects. And each of those day objects is composed of the hotel you will be staying at, the park tickets that you will get. Since Disney World has 5 parks, you're not going to get the park hopper pass, that's too expensive, but trying to figure out what park tickets you're going to have for that day. You also need to figure out your dining. You need to figure out whether you have any special events. What are those dining options? Are they dinner? Are they some other special meal? What is the special event? That'll be some inheritance hierarchy where you make that to be whatever it is that you want to go do. So you can see that this structure, if we were trying to create a generic vacation builder or a vacation planning software, we would want to have the power to be able to figure out the number of days for each day, figure out all of these things. You can imagine if you were passing all of this information to one constructor, if you just had a single constructor for this entire object, how many parameters would you have? You need the number of days. And then you'd have a big overloaded constructor because if you had a single day, you need a constructor for that. If you had 2 days, you need a constructor for that. If you had 3 days, you need a constructor for that. 4 days, a constructor for that. Now imagine that it's 3 days. You would need to start passing in day one's hotel, day one's park tickets, day one's dining. Some of these parameters would be optional, so maybe you pass null sometimes because you're not going to have a special event on day 1 when you are on day 2. This looks really messy and gross. If you're gonna have 20 plus parameters to your constructor, the user can easily make a mistake when calling the constructor, and then they get back a vacation object that's not what they intended. So it just looks really messy. It's messy from the client's perspective. And then you have an overloaded constructor with lots of different overloads because we don't know how many days they're going to be planning for in advance. So it seems like we want a little bit more power here than just the single method that is the constructor for an object. So that's the motivation behind introducing the builder pattern. So you're going to identify the use of the builder pattern when you want to pass a bunch of objects, a bunch of different parameters to a constructor, or you want to overload your constructor to have many, many different options for the constructor. That tells you that instead you should abstract this into a design pattern that has a single call to it, where you offload a lot of that requirement to some sub-objects that are going to construct the solution for you to eventually pass back the entire vacation object. So normally, your construction is handled by a constructor. That only gives us the power of a method. What can a class do that a method cannot do? If we were to give the construction of a vacation the power of a class, what could you do? How could you change something like the overloads of a constructor and phrase that in terms of what a class can do instead of what a method can do? For instance, classes can have an inheritance hierarchy. So if we wanted to construct a vacation object, rather than overloading a constructor to have a 1-day constructor, a 2-day constructor, a 3-day constructor, a 4-day constructor, we could instead have a base vacation object that could then have multiple different subclasses, a 1-day vacation, a 2-day vacation, a 3-day vacation. You do something like this, and now there's subclasses rather than overloaded constructors. Yet another random, another random reference. If anyone knows what the Wandering Inn is, I applaud you. So we have an abstract superclass. So we can make a vacation where day one, we stay at the Wandering Inn, have tickets to Magic Kingdom, have no special event planned, and have dinner at the Castle Diner. And on day two, you can't imagine how many subclasses of this we would have if we wanted to have a subclass that identified every possible configuration of a day. You would need every combination of every place you could stay, cross every park that you could have tickets to, cross every special event that you could attend plus no special event, cross every possible place that you could have dinner. That's gonna be a lot of possibilities, a lot of combinations. I use cross there as the cross product for those of you who haven't seen it before. It's just, you just end up multiplying the number of subclasses. If there are 5 places you could stay, 5 places you could have tickets to, and 5 places you could have dinner, that's 5 times 5 times 5 different subclasses that you would need to make with each of those options. That's way too many. It's disgusting. So the observation, though, that helps us with this is we can break this down. Instead of needing all of this information at the same time, we could break it down into a sequence of steps. The step could be, where are you staying on day one? Figure that out, add it to a vacation object. Where are you going on day one? What park are you visiting on day one? Figure that out, add that to the object. Do you have a special event? If so, where? Add that to your vacation object. So you can turn this building process from the user needs to give you everything up front to maybe the user starts passing in some information. You parse that information and make the associated change to the object. And then you can build some kind of like constructor driver that allows you to interact with the user, ask them a bunch of questions, have them feed you the results, and then use those results to build the object. Seems to make sense. We would have methods like build day, add hotel, things like this that would allow you to, as you get that information, add it to the object. Each method becomes a part of the constructor of the object. Then you could add something like a Boolean complete vacation, and you won't return the object back to the user until you have a complete vacation with all of the associated components. Questions on anything we've talked about so far? So a builder is just an interface and a class. It's going to stand alone with the purpose of using its own inheritance hierarchy and structure to be able to construct an object step by step. Once you've done all of those steps, you arrive at some configuration that is someone's dream vacation. You can then return that vacation object to the user that has the tickets ordered and the dinner reservations and the hotel reservations and the special event tickets. So the next thing we need to think about is separation of concerns. If we have a constructor like process like this, we end up with a very complicated structure. If we don't separate the structure creation from the step creation, then we end up with something that is way too tightly coupled and something that may have some security vulnerabilities. We don't want the user to be able to hack and change this entire process. So here is something that we might want to look at. We have the client. The client is going to call the construct planner. It is going to call the abstract builder. The abstract builder has the methods that are going to build this vacation step by step. Build a day, add a hotel, add a reservation, add a special event, add tickets, and then get a vacation planner object. The concrete vacation builder is actually capable of creating that vacation object and returning it to the abstract builder, which returns it to the client. So this is what creates the actual reservation. The abstract builder is able to add a hotel. It says that anything that does this, any sequence of other kinds of builders that are underneath it, it forces them all to be able to add hotels. So it's just an interface. The driver program would just be calling each of these methods: builder.buildDay, builder.addHotel, builder.addTickets. And then you could create a new object from this, builder.getVacationPlanner, that returns the vacation planner object that has all of the associated tickets that you added to your reservation through the driver. We'll see that there are still a couple issues with this, but this is a very good structure to start with. Questions on this structure or any of the associated interactions? The reason we have this abstract builder is because we may want to be able to construct this object in multiple different ways. So because of this, you can instantiate, or I guess implement is the better word, that interface from multiple concrete builders. And that allows you to use the same information to construct different objects with those same steps. The example that I really like is the same information is required to construct an actual automobile and to write its manual. Very different objects. One is a car that can drive, one is just a bunch of information about the car, but the same information is used as the technical specifications to building the car and putting those technical specifications in writing into the manual. So you might have a car builder and a manual builder that both use the same interface that communicate with the same client as the client specifies what they want out of their car, or I don't know, the manufacturer specifies that. You can build both the manual and the car off the same information. So going back to our vacation planning example, you may have different kinds of vacations. You may have a budget vacation, a luxury vacation. So the luxury vacation has, in addition to the hotel and the park tickets, there's a taxi to pick you up, a suite instead of a room at a hotel. So you can now query the user and have the user change exactly what kinds of information they are giving to you to build different kinds of vacation objects. So we can make a separate concrete builder that inherits from the same abstract builder interface. This allows us to not duplicate our code as we do this or have to refactor as we add in new builders. If we want to add a luxury vacation on top of the existing vacation, now we just make a new builder for that. None of the existing logic in our original vacation builder needs to change in order to add the luxury vacation builder. That way nothing can break. We don't copy and paste any code. Any code that stays the same could be abstracted into its own abstract class. The abstract class implements the interface, and then each of the luxury vacation, the vacation extend the abstract class. And you could do that to avoid your code duplication. All of this is great until we realize there are still security vulnerabilities. We don't want to be communicating directly to the object that is putting this together. We don't want the user calling those methods directly. We actually want to possibly insert some logic in the middle of that. The user tells you what you want. If you want some logic in there to process what they have said and to interact with the builder, this is what we have, what we call a director class for. The director is who is in charge of putting the reservation together. I like to think of it as you're talking to a travel agent. And this travel agent is going to abstract all of the really annoying details of your vacation. And all you need to do is communicate what you want with the travel agent. And then the travel agent knows what to do in order to construct your vacation for you so that you don't have to do any of the work. That's the purpose of the director. Think of the director like your travel agent. So it's also important to note that in the prior implementation, the client is the one who's putting everything together. The client needs to know, I want to add this hotel to the vacation. I need to know which method to call to do that. I want to add these particular park tickets. I need to know exactly what call to do with that. So the director can abstract that and allow the director knows how to do the calls, and that allows the client to query that in English instead of Java. The client needs to know what the name of the object that's being constructed is, that there is a vacation planner object, that it needs to know the internal structure of your vacation planner. It would be much nicer if you could interface with a director who knows all of that and allows the client to be the dumb client who doesn't know anything about computer science. It's always a good thing to abstract away from. You are an expert in computer science, your client is not. So it's very easy to get bugs in your code that the client introduces if they don't know that the order that the steps need to be called in. Especially if there's something like, you can't book the tickets without a hotel room. It's not the case in this vacation object probably, but in a complicated scenario, you can imagine that there is some kind of time-based flowchart where people need to do something before something else, or there are prerequisites in order to construct the object, which means that it's the client's responsibility to catch that. The director's task is to abstract all of that and make sure you are querying the client for the information that is relevant, or this is where you would catch the exception logic of, I'm trying to construct something in the wrong order. The director would then communicate back to you in English, you're not allowed to do that yet. Would you like to instead book a hotel first? Something that would translate the exception that is the builder trying to add something too soon to English to allow the user to know what to do differently. So abstracting the sequence of calls into an order, the client calls directly. So we put all of this together and we get the final UML for the builder pattern. And it looks like this. So the client, note that the client no longer communicates directly with the builder. The client communicates with the director. The director makes the builder object. So the director houses the builder constructor or the concrete builder constructors, but it works from the builder interface, which may have multiple different concrete builders that implement it. This allows the client communicating with the director who communicates with the builder, making the associated builder object. Now the client has no idea what's going on underneath the hood, which is good from the client's perspective. You've abstracted out the complexity of building this object. And this allows you to have full creative control over what the client knows, what the client requests, how the director logically handles those requests with respect to the builders that it is building, so that it can return, in this case, a vacation planner object back to the client. But the client doesn't even need to know that. They're just going to get an email confirmation that says, it's all booked. Here's all of the information that you need. Here are all of your tickets. Here's everything. And this is how most of these apps work that do things like the City Pass app, for instance, if you're going on vacation somewhere and want to book a bunch of things through one app. I did this myself when I went to New York. Very convenient. I didn't need to know all of the underlying calls or anything that happened underneath the hood. I just said, I want to go here and here and here and here. And then I just had QR codes in that app for all of those things. A lot of other work went on underneath the hood, but I didn't want to worry about it. I'm on vacation. Questions about this UML or this structure? So the builder makes the product is returned to the director. There may be multiple products associated with the director figuring out and building this complex, like a vacation is made up of multiple objects. So there are lots of different concrete builders for this that all work through the same interface, or maybe even you have different interfaces and the director is figuring out which interface to call, which concrete builder to instantiate within that. And that works to create the object that is returned to the user. Questions? Reasonably complicated idea? Let's go through an example. This has the car builder and the car manual builder again, because this is such a good example. So the client, in this case, wants to make some kind of car, and the director knows a couple of different ways to make a car. It can either make an SUV or it can make a sports car. So it's going to call the builder interface, and the builder interface knows how to, it says that anything that implements this needs to be able to set the number of seats, set the engine, set the trip computer, and set the GPS. Implementing this interface are both the car construction and the car manual construction. And the car builder, when it sets the seats, is actually going to construct and put the seats into an automobile. When the car manual builder sets the seats, it's going to go to the appropriate place in the manual and talk about how many seats are in your car and any associated information that the manual would need with regard to the number of seats. It would make all of those associated changes maybe to a base manual. Set the engine. The set engine in the car builder is going to actually put an engine in a physical car, and the car manual builder is going to make changes to a manual prototype that is going to explain anything that you'd need to know about this particular engine, as opposed to some other engine. And you can imagine now that the builder is able to produce now, knows how to produce both the car and the car manual, such that that gets returned as an object, an SUV and an SUV manual, or a sports car and a sports car manual, to the director, which returns them to the client. And this way, the client can call new car builder and then make a sports car and things like get result. And now we have a car object that is a sports car that was made by this builder. And none of the logic of how exactly this was constructed is known by the client. They can just say, make sports car, and all of the magic happens underneath the hood. Very useful if you want to hide implementation details or construction details, because oftentimes from the client's perspective, that construction process is unnecessary to know or even interact with. All of that logic can be hidden underneath the hood in the director and in the builder interface and concrete classes. Questions on this UML? Questions on the example of this builder and how it works? As you start your project, you're going to be designing where these design patterns go inside of a larger scoped project. My recommendation for as you start to go through this process is to refer back to these UMLs and then base your own UMLs off of this. So if you decide, I'll spoil what the project is, I probably talked about it, you're making an airline ticketing system and an airline reservation system. You want to be able to book a reservation for your entire family that has tickets from some home airport to some destination airport. And you can do things like decorate your seat with the first class seat object. You can do things like, how are you going to build each of these ticket objects? You're going to have a ticket builder because the client doesn't want to worry about the logic of building the actual ticket object. They just want to say, I want a ticket to there. So you should be able to hide all of that internal logic inside of a director and inside of a builder. My experience with this project in the past is that people don't go back to these UMLs and think, all right, the builder part of this is the ticket builder. So the ticket builder needs to have this structure that has a director, has an interface, and has some concrete classes. So as you identify the parts of your project that you want to apply the design pattern to, go back to the design pattern UML and actually structure your code, all of your classes and class design based on this. It will make your life so much easier if you start out doing that. All right. When do we want to use the builder design pattern? Because obviously this is making our code significantly more complex. This is not something that we want to do unless it's actually going to save the client some headache. Or it's going to create structure that removes a bunch of code redundancy because we have a bunch of overloaded constructors. So when should we use the builder? You have an overloaded constructor that has 5 possibilities, 7 possibilities, 10 possibilities. The more different overloaded constructors you have, it might be worth abstracting this into a builder pattern. So you might have a pizza class, and you can construct a pizza with just the size. You can construct a pizza with the size and whether it has cheese. You can construct a pizza with a size, whether it has cheese and whether it has pepperoni. You can construct a pizza with, this gets incredibly repetitive and tells you maybe you should have a pizza builder instead of an overloaded constructor with a bunch of different possibilities. If we want to construct a bunch of the same product, but in multiple different ways. This is like the car where you want to make an SUV or make a sports car. If you want to make a bunch of different kinds of vacation products, if you can identify that kind of structure in the construction of an object, you may want to use the builder pattern. If the user wants to create an instance of this object and you don't want to make it yet, you want to defer some parts of that construction to a later time, and you don't want the object to break. It would be something like, you can imagine that the user is filling out a multi-page form and they're going to submit and hit the next button after each time. You don't want to charge them until they've entered all of that information. And then when they click finalize, then you go charge them. So you'd be building the object step by step as they submit more and more information. And only once you have a finalized product, then do you want to charge them for the entirety of the information that they submitted over the course of multiple of those pages, clicking next, clicking next, clicking next. Questions on identifying when to use the builder pattern? Last thing we need to talk about with regards to it is just some benefits and detriments. So benefits of the builder pattern. The client can't access the unfinished product. So once you submit information to the builder, the client can't go modify it. It would be very easy if we were trying to do things like figure out how much to charge them for a vacation. If we have them, we tell them to go buy tickets for all of these things, and at the very last minute, we tell them, make it the cheapest thing, but still give me the tickets for the more expensive things a bit. So we don't want to access the unfinished product. We want the submissions that the user gives us to be finalized, unless they're interacting with some method in the builder that allows them to change something that they've already submitted. You have to go through the director's methods in order to change the underlying builder object. That gives us that encapsulation that we're looking for. So it also allows you to construct an object with multiple steps. It can defer certain construction steps until an arbitrary later date where you're saving the internal state of the object in the meantime. That's also not something that you can do with just a method. A method you have to run to completion. You can't just say, pause this method, we're going to continue this at a later date. But you can do that with a class because it has state. You can modify fields in a class, save the state of that object, and then come back to it at a later date. We can also write single construction code that we can then use in multiple places. If you're overloading your constructor and you have 5 different constructors and 9 of the 10 steps are the same between all of those constructors, you have no other way than just to copy and paste that. I mean, maybe you could come up with some kind of, there's no way. You come up with a method, you have to factor it out and then call that method within each constructor, and that gets kind of messy. But yeah, it's much easier if you use a builder design pattern to factor all of that out into an abstract class that can be called, or it becomes a builder method that does all of that logic for you. It adheres to the single responsibility principle. This is one of those object-oriented principles that we've been talking about throughout the quarter. We have the construction code, and it's different. The construction is different from the logic, the business logic of the product. So we're, instead of trying to construct all of that and keep track of all of that in the same constructor, we're saying there's the director that's handling the business logic and the builder that's handling the construction code. And that way we have different classes for different responsibilities, rather than a single method or a single class that's responsible for all of it. So lots of good benefits to using the builder pattern. Where there are benefits, there are always detriments. So as we do this, we need to make multiple new classes. So the size of our project is going to increase. Overall code complexity increases because we need to not just be aware of the logic, we need to be aware of the necessary structure behind that logic. That logic is not all going to be in the same place. It's going to be spread out amongst a client that calls a director that's composed of a builder that has many different concrete class implementations. And that's if there's just a single builder. You might have multiple different builders within a single director. And so you can easily find a builder that is 20 classes by itself. And that's a lot to add to your project. It's a lot of complexity to add. That's a lot that you now need to maintain. But that said, the maintenance is fairly easy if it's structured in such a way that it's easy to find where any bug might be. And it's easier to extend because you can just add new builders or add new concrete builders to existing builder interfaces that allow you to expand on your existing vacation planner system, for instance, or car construction system. You don't need to go back and change any of the existing code because you're just adding functionality, not modifying any of the existing functionality. Questions on any of these benefits or detriments? All right, well, that's everything that I'm planning to talk about Builder. It's one of the shorter design patterns. We'll have some of these that are very, very long, like the next one we're going to talk about is Factory, and it is going to take probably 3 class periods to go over because it's just that long. I'm thinking though that I want to get people off on the right foot with regards to the decorator lab. So maybe for tomorrow's class, we have an in-class workday where we get started on the decorator. And that way I can help you to make sure that you are minimizing that. I do want it to be due after the 8th, but I also want people to be able to get started, get stuck, ask me questions about that. So that would be a useful, I think, way to spend some class time, because I think we're in a pretty good place with regards to the content that we are covering. Now we just need to get through the decorator lab, make that due. The builder lab, make that due. The project, start that design. And we're able to do all of that with the material that we've covered now. So I think there's a lot of opportunity for some in-class work. So starting tomorrow, we are going to do that. And I will let class go a few minutes early.